Okay, welcome back, everybody. I know that you enjoyed that previous section on proof so much, I thought I would bring back proof again. But this time it's a different type of proof. It's not a two-column proof. It's what's called coordinate proofs. Um, so what is a coordinate proof? Well, a coordinate proof is a style of proof that uses coordinate geometry and algebra. So it's not the two-column proof. And I have two examples today to go through with you of proofs using this new style, coordinate proofs. And then there'll be an assignment that goes along with that. Okay, so look at the figure here that you see, the drawing, and as usual with a proof, we have some given information and a diagram, and then what we're trying to prove. It's just that we kind of do things a little bit differently. So if you look at that diagram, you'll see that it's given that triangle ABC here has vertices A at 0, 6, B at 0, 0, and C at 4, 0. And we're also given that point D is a midpoint of segment AC here, that hypotenuse of that triangle. It's a right triangle. So we're trying to prove that the area of triangle DBC, so let me highlight that again so you know we're talking about this smaller one, trying to find this area and show that that's going to be exactly 1/2 of the area of the right triangle right here. So we're going to do that using coordinates. The first thing we want to do, though, is use that part of the given where they say that point D is the midpoint of segment AC. So remember, the midpoint formula is when you take the midpoint of a line segment and you find its coordinates by averaging the x coordinates of the endpoints and the y coordinates of the endpoints. So if we look at points A and C and add those x's up and divide by 2, we got 0 plus 4 is 4 divided by 2 is 2. So the x coordinate of point D, the midpoint, is a 2. And then we do the same thing for the y coordinates of points A and C. So we add those up. 6 plus 0 is 6. Divided by 2 is 3. So now we know the coordinates of the midpoint of segment AC, which is 2, 3. That's going to help us with our proof. So the kind of a strategy, what we're going to do is we're going to find the area of the right triangle. That's obviously the bigger one. And then we're going to find the area of the small yellow triangle. And we're just going to show that that area of the smaller triangle is exactly 1/2 of the area of the larger triangle. Okay, so let's look at, first of all, the area of the larger triangle, so the area of triangle ABC. So we know the area formula for a triangle is 1/2 times base times height. So if you look at that bigger triangle, the base is 4, so 1/2 times 4, and the height is 6, so 1/2 times 4 times 6 is 1/2 of 24, that's 12. So that area of that greater triangle ABC is 12. Now take a look at the yellow triangle. So we'll calculate the area of that one. So the area of triangle DBC, same formula. That's 1/2 times base times height. If you look at that area, that base of that smaller triangle, it's 4. So 1/2 times 4, but its height is only 3 there. So it's 1/2 times 4 times 3. So it's 1/2 of 12, which is 6. So that's your proof, really. You just proved that the area of that smaller triangle, DBC, is 1/2 of the area of the larger triangle, ABC, because 6 is half of 12. That's your proof. Okay, well, if you followed that, you should be able to easily follow then our next and last proof here. This time, though, we're not going to have graph paper and actual numbers here. We're going to just have a sketch, and this is more along the lines of what we care about as far as doing geometry coordinate proofs. Okay, so it's a very similar situation. So you're given a diagram, and you got a triangle there in the first quadrant. So angle B is a right angle. That's noted there with the red ink. And so you have a right triangle there, triangle ABC. You're also given, just as in the previous example, that point D is a midpoint of segment AC. This time, though, we don't have any numbers and we don't have any graph paper to count off squares, so we're going to have to just still do the same thing with variables. So we want to get the coordinates of point D again, so that's the midpoint of segment AC. So again, we're going to add those x coordinates up and divide by 2. So if you add 0 and 2n, that gets 2n, and then divide 2n by 2, that gives you n. And so the first coordinate of point D is n. Repeat that process for the y coordinates. So if you take 2j and add it to 0, you're adding the y coordinates, that's 2j, and then divide by 2, that's going to be j. So we now know the coordinates of the midpoint of segment AC is n comma j. Same thing here, we're going to prove, and again I'll highlight these triangles. We're going to prove the area of that small triangle DBC. Prove that the area of this one is going to be half the area of triangle ABC, the larger one. This time, except we don't know any coordinates to help us. Okay, but it's done the same way. So let's calculate, first of all, the area of triangle ABC. And again, it's 1/2 times base times height. So if 1/2 the base, this time is going to be 2n. And the height is going to be 2j. Okay, so it's going to be 1/2 of 4nj, which is 2nj. Okay. Let's do also then the area of the smaller triangle, the yellow one. So the area of triangle DBC. Oops. Let's calculate that area. It's also 1/2 times base times height, just as all triangles are. The base of that triangle then is also 2n. But the height this time, you can just look at the y coordinate of point D for the height, so that's j. So if you take 1/2 times 2n times j, that's just going to be nj. And so you can see from the two results there that there's the area of the larger one, and there's the area of the smaller one, and the smaller one has exactly the 1/2 of the area of the larger one. Okay, so that's a legitimate method of proof, just like a two-column proof is. So the purpose of this lesson is to introduce coordinate proofs where you use coordinates and to prove what's required of you. And so, but they have the same elements as before. We have a diagram, we have what's given, and what you're trying to prove. So if you look at those two examples, if you need to go back, but otherwise that'll be it. So the worksheet is posted for this, and so go ahead and try that, and let's see how you're doing that. Okay, good luck.